All right, so Unit 13. Three main topics. Law of sines, law of cosines, and a new area formula. We'll do law of sines and cosines together today, together again on Monday, and then we'll review and do area on Tuesday, and then block day we'll test after we come back from the break. So tomorrow is just a catch-up day. So if you guys online, finish this worksheet, work on something else, head for spring break, whatever works for you. All right, so today we're going to do law of sines. And then, since it's a block day and law of sines isn't really that long or that difficult, I'll give you time to work on the worksheet for a few minutes. I think enough time to finish the assignment even, and then we'll do law of cosines. And so hopefully your only homework assignment will be the law of cosines worksheet. All right, let's start with some random triangle. It does not have to be a right triangle. All right, gentlemen, join me. Let's take notes, or at least watch. So triangle ABC. This might seem minor, but it's super important that the side goes across from the angle of the same name. So side A, side B, and side C, once the angles are on there, the sides are not random. Side A has to go across from A, side B across from angle B, and side C across from angle C. Now here's the law of sines. The sine of angle A over side A equals the sine of angle B over side B. You want to take a guess at what the third piece of this equation is? Sine of angle C over C. Now that looks a little bit weird maybe because it's like a three-sided equation, so we don't really do those very much. And here's the deal, you use two pieces at a time. So it wouldn't be wrong to write them all out, but you don't use them that way. You pick out the two that you need. And we'll talk more about how to know which two to use in a minute. So you either use A and B, B and C, or A and C, but never all three at once because there'd just be too much mess going on.
So for this one's going to be letter specific, like the capital lowercase.
Yes, capital and lowercase makes a big difference on this one. Capital letters are the angles, lowercase letters are the sides. Now, we also have to know when to use law of sines versus when to use law of cosines. And there's a couple ways to think of it.
When the question asks.
Well, when the question asks. But the trouble is the question isn't going to say use law of sines to solve the triangle. The question is going to say solve the triangle, and you're going to have to know which one to use. Law of cosines, which we're not doing first. Do you recognize these kinds of letters from your geometry days?
Side, 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 angle, side.
Side, 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 angle, side. If that's the information you have, then you use law of cosines. Do you remember the other combinations of letters that there were that were allowed? You were allowed to use? That's the one you can't use, right? Because that one makes a bad word. So angle, side, angle, 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 side. Now, we're not going to do it, but the angle, side, side format, note how I wrote that, that leads to what's called the ambiguous case. That's a little bit beyond what we're going to do. But you remember in geometry, you weren't allowed to use this one to say triangles were congruent to each other, because there could be two triangles that had the same angle, side, side that were not congruent to each other. So you weren't allowed to use this in geometry, and it's not going to work here either. So, and again, it's not because it makes a bad word. That's just how we remember it. It's because there are potentially two triangles with the same angle side side that aren't the same triangle.
Look the other way.
Would
Angle doesn't work
All angles.
because you don't know how big the triangle is. Right? Those two triangles have the same angle, but they're not the same.
They may possibly be congruent, but
So angle is definitely out. Angle side is a maybe, and because it's a maybe, we're not going to deal with it. The other two or other four, you have to know which one to use. Maybe the easiest way to say it is you use law of sines if you have two angles. That's another way to think of it. If you have two angles, you use law of sines. Probably the best news of all is that if you use the wrong formula, you won't get a wrong answer. It just won't work. So if you try to use law of cosines and it's a law of sines problem, you won't have enough information and it won't work. And vice versa. If you try to use law of, I forget which one I said, but if you use the wrong one, you don't get a wrong answer. You just don't have enough information. So even if you forget all this and try one and it's like, this doesn't seem right, try the other one. You probably should have started with the other one. All right, an example. Angle B equals 31 degrees. Angle C equals 20 degrees. Side C equals 210. Solve the triangle. Thoughts on what we should do first? Draw the picture. If you want to spend the time to draw it kind of accurately, that's fine, but it's not really necessary. So just draw some triangle ABC. Angle B is 31. Angle C is 20. Side C, here's where it's important. Side C has to be across from angle C. Side A across from angle A. Side B across from angle B. Do you know what it means when it says solve the triangle? Have we used that?
you gotta find the other angle on the other side.
Yeah, it's a quick way of saying find all the missing information. Very formally, find all the missing stuff. So whatever you don't know, find it. But that way you can give one set of instructions for the whole test rather than problem by problem. Find angle A and side B. Just find everything. Solve the triangle.
The other angle's 129.
What did you find first?
The other angle.
And how did you know to...
You add the other two and then subtract that from 180.
So it's the old 180 rule that you learned in 6th grade, maybe 7th grade, 8th grade, somewhere in there.
Equals 129.
All the angles in a triangle add to 180. So 180 minus the other two is 129. You can put it in the triangle if you would like to. You don't have to. I usually do because it helps me keep track of what I know and what I don't know. That way I'll know when I finish the problem, when I have everything. All right, how do we know this is a law of sines problem rather than a law of cosines problem? Right, because we were given two angles. The other way we know is we're doing law of sines right now, so of course it's a law of sines problem. But the real reason is we were given two angles. Let's be careful, we were given those two angles. So it's a law of sines problem. Let's see. What do we want to... We use them two at a time, like they're sort of paired up with whoever's across from each other. So we have three pairs, but we only want to use two of them. Do you know which is one of the pairs we definitely want to use? Why the C stuff, the C pair? Because we know both of them. So let's definitely use the C information because we have both of them. Sine of 210 over 20 equals... Wait, I did that wrong, didn't I? That's a common mistake. I wish I could say I did that on purpose to draw attention to it. What did I do wrong? Do you see what's wrong with that? You got to take the sine of an angle. Never take the sine of a side. It's always the sine of an angle. And then, while that dries, on the other side, so I've got the C stuff. Now I can either use the A stuff or the B stuff. It doesn't matter. I can only use, two at a time. So I guess I'll just pick the A stuff because it's alphabetical maybe. I don't know. Sine 129 over A. There we go. Sine of angle over side. Sine of angle over side. Okay, algebra experts, how would you like to solve that? Butterfly. I've not heard it called butterfly. I think I know what you mean. Cross multiply there, butterfly. A sine 20 equals 210 sine 129. This is why we have a calculator. Our calculator, I was about to make another mistake on this one.
You need to be in degree.
Need to be in degree mode. So mode degree.
Okay.
So 210 sine 129 divided by sine of 20. So A equals 477.167. Yeah. Let me give you the...
Thank you.
Yep. So there's side A. What's left to find? Side B. Since C was the original information, I think it's probably wise to start or to use the original information. We could use the A stuff, but if I messed up finding something in A, then it's going to mess up the rest of the problem. So let's use that original information. What am I going to set that equal to? That's the C stuff. I need to use the B stuff. I'm going to press pause and see if you can finish this out. So set up the equation, then cross multiply, use the calculator, and see if you can find the missing side. It should be 3. So sine of C over C equals sine of B over B. Cross multiply or butterfly or whatever your teacher called it when you first learned this. Go to the calculator. There's my missing side. I don't have to put it on the picture, but if it helps you keep track of what you know and what you don't know, then maybe it's a good idea. Now I can see I have all 3 sides, I have all 3 angles.
So do we need to go to 3 decimal points, or is that just 3 numbers before the decimal point?
No, always use 3 decimal points unless we say otherwise. And the reason is, in calculus, that's what the AP test wants. So that's, looking way out, but you may as well get in the habit now. All right, there's one minor check you can do on your triangles, and that is that the smallest side should be across from the smallest angle. Right, I think that makes sense. If you have a really small angle, then the side across from the small angle is going to be small. And the largest side should be across from the largest angle. So that provides a little bit of a check. It doesn't guarantee you got the problem right, but my smallest side's across from my smallest angle, my biggest side's across from my biggest angle, so I've at least check marked that part of it. All right, these are pretty easy. Like, just set it up with across from each other, pick one that you know, and then grab the other one, cross multiply, and go from there. I'm going to give you a few minutes to work on the worksheet, maybe a few minutes enough to solve it or to finish it, and then we'll do law of cosines. That way we kind of just break up the note-taking time here.